Hello everybody, thank you for joining me today. I'm going to present you the newest features in Microgateway 5.0. My name is Stefan Dietiker and I'm the product manager of Airlock Microgateway. I have a few topics that I want to cover. First, the main new features of Microgateway 5.0. Afterwards, I like to mention some news about the Airlock Academy. Today, I'm introducing Microgateway 5.0. This release is about one theme: stronger security with less operational friction. Step-up authentication for OIDC, so we can keep normal flow smooth but require higher assurance only when it matters. ICAP malware scanning support, so HTTP requests can be scanned by your antivirus scanner and blocked before threats spread. On top of that, we've made key improvements in post-quantum cryptography, readiness, tracing, and common expression language-based validation. As mentioned in the last release news, Microgateway 5.0 retires the sidecar approach and now supports only Kubernetes Gateway API. This focus let us simplify deployment and implement a standard Kubernetes native traffic model via Gateway API. We also reworked the documentation end-to-end. Because we describe one approach, Gateway API, the setup is less complex and the configuration steps are much clearer. Some parts of the web application, like admin screens, member areas, or high-risk transactions, need stronger authentication than the default. With step-up authentication, we can ask for that stronger login only when the user reaches those sensitive areas. Microgateway now supports ACR values in OpenID Connect. Concretely, we can request a specific assurance level using the standard ACR values parameter, and then verify what happened using the ACR claim returned in the ID token. So if a user is currently signed in with a low assurance, Microgateway can trigger a step-up at the OIDC provider, typically meaning an extra factor or stronger method before allowing access. We kept the configuration simple. You extend the existing access control policy and declare which ACR level is required. Microgateway handles requesting it from the provider and includes redirect loop protection by rechecking the resulting token and stop the step-up flow once the required ACR is met. Malware didn't disappear just because we moved to containers in Kubernetes. Users still upload documents, archives, and binaries, and that's a very common entry point for threats. That's why Microgateway now supports ICAP, the standard protocol for handling of HTTP requests content to an external service for processing. In other words, Microgateway can act as an ICAP client and ask an ICAP server to inspect content in transit. A typical use case is connecting an external antivirus scanner. Microgateway forwards relevant traffic for scanning, and if the scanner returns a malicious verdict, Microgateway blocks the upload before the web applications ever sees it. Post-quantum cryptography algorithms are now available to all our microgateway customers. We follow the principle of secure by default, which is why the new ciphers are enabled in microgateway for front-end connections. These new ciphers will be negotiated automatically if a client supports them. This way, the risk of hovers now, decrypt later is reduced. The new ciphers are by default active for front-end connections and can be enabled for back-end connections as well. A standard format for post-quantum safe certificates is still under development. Once the standard becomes widely accepted, we will integrate support for this format. Please note, the key exchange is hybrid, combining both classical algorithms and post-quantum secure mechanism to ensure security against both classical and post-quantum attacks. The Grafana dashboards show the used TLS key exchange groups, which provides visibility into post-quantum safe usage. Troubleshooting in Kubernetes can be hard because a single request typically crosses multiple pods and services. Logs alone often don't tell you where the time went or which hop failed. That's exactly what distributed tracing is for. It lets you follow a request end to end and see the sequence and timing of each component involved. In OpenTelemetry terms, a trace is made of spans, time operations with parent-child relationships, so you can quickly spot the slow hop and understand dependencies. The trace context is propagated between services using standards. With Microgateway, you can enable tracing and it will export spans to an OpenTelemetry compatible backend, so you can investigate complex issues with proper trace visualization instead of guessing. Microgateway 5.0 now validates its custom resources using Common Expression Language. In previous Microgateway versions, we relied on a validating admission webhook for these checks. We replaced that with cell validation rules directly in the CRD schema. These rules are evaluated in process by Kubernetes, which removes the need to run and maintain an extra webhook component. This also simplifies operations. Webhook-based validations typically comes with TLS certificate and CA bundle management, so the API server can trust the webhook endpoint. We previously handled that via Cert Manager. Since the webhook is gone, the Cert Manager is no longer a prerequisite for deploying Microgateway. Of course, you can still use Cert Manager elsewhere in your environment. We do have some news about Airlock Academy I like to mention. In the past months, we worked on the following Academy topics. We created and improved a total of 7 Microgateway labs, which can be run for self-study purposes. The labs cover different aspects like initial setup, first web application, and different integration tasks. Try it out. The first on-site training for Microgateway is planned for end of March 2026. Further training dates are published on our website. I'd like to thank you for your time and hope that you enjoy the new Microgateway release.